Okay, so before we talk specifically about air pressure in the lungs, a couple of things you need to know regarding air pressure. So the first and most important rule is it always moves from high to low. Okay, so if we have an area of high pressure and an area of low pressure, the air always moves in that direction. Okay, it's the same on the small scale, what's happening in your lungs, breathing in, breathing out, but also on the huge global weather scale. Okay, so when we get wind blowing off the desert, when we get the Santa Ana winds, the way that's happening is we have a low pressure over coastal California and high pressure in the desert, and the air rushes from the high pressure to the low pressure. The bigger the difference, the faster it moves, the stronger the wind. Okay, so that's the first key thing is it moves from high to low always. Okay, that's an absolute truth. Now, a couple of other things I want to explain to you before we get on to talking about the lungs is how can we create difference in pressure to control which way the air is moving. Okay, so the first one, I just wanted to show you these examples. So here we have two equal size boxes. In the first, we have 7 molecules represented by the X's moving around, creating pressure against the walls of the box. Okay, so one way we can increase pressure is by pushing more molecules into the box. So now instead of 7, I have 14. Okay, so we've doubled the pressure because we've doubled the amount of molecules inside of the same volume. Okay, so that's going to increase the pressure. Now, in our lungs, it doesn't work this way. Okay, it's hard for us to push things into a box. So what we do is the second scenario. Okay, basically we change the size of the box. So if both of these have 7 molecules of air inside them, if I make this box smaller, the air pressure goes up because they're in a more confined space. Okay, they bump into the side more, they're moving around and hitting the sides, creating that pressure. So this is how it works with our lungs is we change the size of the box, making it smaller or bigger to change the pressure relative to the air outside. Okay, there is a third way that we can alter pressure, which is temperature, but it's not really a good idea to heat up and cool down your lungs. So we don't do that. Now, if I spin this around, I have a couple lung diagrams. Now, when you are holding your breath or that moment in between breathing, the air pressure on the inside of your lungs is the same as what it is outside. So the air pressure is the same, we get no movement. Now, for us to breathe in, we have to lower the pressure inside of our lungs relative to what's outside. Okay, so let's use a fake number and say the outside pressure equals 10. Now that's just a made up number, but I just want to use it to demonstrate. So when you're not breathing in or out, pressure outside is 10, pressure inside the lungs is 10. Now for us to make this pressure lower, we have to change the size of the box. So when you breathe in, our chest gets nice and big. We have a bigger box, and then that lowers the inside pressure. So what happens is the intercostal muscles go up and out, and our diaphragm flattens. Now we have this much bigger box surrounding our lungs, so we get a lower pressure. When it's lower compared to the outside, air rushes in. And you can see that in real life, okay? Make that big chest, air comes in, okay? Air gets sucked in. Now the opposite is when we breathe out. As you breathe out, you feel your chest coming in and the diaphragm comes up. That shrinks the box, increases the pressure, and so air will be pushed out. So let's say making this box makes the inside, sorry, I skipped this, inside pressure 5. So we get movement